Today we're talking about the probability of independent and dependent events. An independent event is an event for which the outcome of one event does not affect the probability of the other. And a dependent event is an event for which the outcome of the first event affects the outcome of the second. You've probably heard about these in science at some point in life. So we're going to decide whether each set of events are dependent or independent. Explain your answer. Kathy draws a 4 from a set of cards numbered 1 through 10 and rolls a 2 on the number cube. Since the outcome of drawing a card does not affect the outcome of the rolling of the cube, the events are independent. Okay? Because it doesn't matter what card she drew, she's rolling a dice. No big deal. Find the probability of choosing a green marble at random from a bag containing 5 green and 10 white marbles, and then flipping a coin and getting tails. Now, same thing. The outcome of choosing a marble does not affect the outcome of flipping the coin, so the events are independent. Okay, so now we're going to look at finding the probability of getting a green marble and getting tails. So the probability of getting a green marble, there are 5 green out of 15 total, because 5 plus 10 is 15. Okay, or you can simplify that to 1/3. So I'm going to go ahead and do that just because it makes multiplying a little bit easier. 1/3. And then flipping a coin and getting tails, there are 1 tail on the 2 sides. So we multiply those together, and the probability of choosing a green marble and a coin landing on tails is 1/6. So it's kind of like the fundamental counting principle in a way. What is the probability of 1 times the probability of a second? Okay? And the word "and," when we're working with probability, is a clue that you are going to multiply your 2 probabilities together. A reading list contains 5 historical books and 3 science fiction books. What is the probability that Juan will randomly choose a historical book for his first report and a science fiction book for his second report? The first choice changes the number of books left, because if he pulls a book out, now instead of 8 books being there, he has 7 to choose from. So, because the number of books have changed, the events are dependent. So the probability of getting a historical book at first is 5 out of 8, because there were 5 historical books out of 8 total books. Okay? So, then the probability of getting a science fiction, we're going to pretend that he got that historical fiction for his first report. So now we're saying that the number of books is 7, and that there are 3 science fiction books. So 3 out of 7. Okay? Because there's still 3 science fiction books, because that's a 3, not a 5, by the way. He already grabbed his historical book. So the probability of getting his historical book and then a science fiction book is the probability of getting historical book plus the probability after we took the historical book out and our denominator changed to 7. So we're going to multiply our 2 events, 5/8 times 3/7, and when we multiply straight across, we get 15 out of 56. So there is a 15/56th chance that Juan will get a historical book for his first report and a science report for his second report. Do your check it outs.